Hello everyone, in this video we'll be discussing about compile time polymorphism, or more specifically function overloading. So I have a class called class A over here, which consists of a private data member int, and some of the public functions are its constructor, a default constructor which just prints out A to the console, the function show, which actually prints out the value of A to the console. Then what I have done is that I have three functions, each called dummy. Now what we see is that let's actually try to compile such a program wherein I create an object of class A. So AA. Let's try to compile this program and let's see what errors arise. No errors, meaning this is completely valid. Now what we are using over here is called function overloading. We can see that each of these functions has the same name, but where they differ is in the parameters themselves. So here we have here this function in its signature takes in an integer value as its parameter. Here the second function dummy takes in a float value as a parameter, and in the last one we have two parameters rather. So what this allows us to do is it allows us to use the same name in order to achieve different goals. So in the first two goals, I'm trying to just simply print out whatever value is being inputted, but we could have done other calculations or operations as well. And in the last one too, what I'm doing is I'm printing out both the values which are being inputted. So in this way, function overloading allows you to use the same name in order to achieve different goals or different functionalities. So here what I can do is I can call a.dummy with 10. I can call a.dummy with 10.23, and I can call a.dummy with 10.2 comma 10. Let's see what the error is over here. So the call of overloaded dummy is ambiguous. So why is it ambiguous? It is because since 10.23 is a number itself, if float was not actually defined, what it'll do is it'll actually round this number up and then call it for the integer, the dummy function, which takes in an integer as a parameter. So this is one thing which you'll have to keep in mind while trying to overload functions, is that sometimes there are implicit conversions between values being passed on to functions, especially in numbers, in the case of numbers. So it may not always work the way you actually want it to. How we can resolve this is simply by changing the definition itself. So what if I just don't have such a function, or let's just say I don't want to actually input any value here, and I'll just print out hello. So in this case, we won't actually have any ambiguity because a function for float won't actually exist. Now let's just try to run this and see what actually happens. We see that there is no compile time error, meaning that this will actually get converted or rounded off. Again, we see that it is A for the constructor when it's when we are actually creating the object. 10 and 10, meaning 10.23 is actually getting rounded off to 10, and hence it is being called forward. And dummy takes in 10.2 and 10, and that's what it is printing out. Now let's see what happens if we do it as float. So similarly, we'll have implicit conversions from int to float. This remains double to float, and this will be double to float, and float int to int. So we see that even if we give it integer or float over here, it will implicitly convert the value either from integer to float or float to integer to match its needs. So this has been all about function overloading. Again, just to summarize, function overloading, we have different functions, same name, but different functionalities depending upon the parameters which we are actually passing. So it could differ in the number of parameters or the type of the parameters themselves. Thank you.